Okay, good afternoon, everyone. Welcome to the class for today. So we'll continue as we did from the last class on Wednesday, where we talked about AI as an area that a developer will be interested in pulling the capabilities of AI into your products. Of course, we ended up with this slide where we talked about the difference between who is an AI engineer and who is an ML engineer. I think it's very clear now. I hope it is very clear. What I have seen is that an AI engineer, like I said, brings the power of AI to the customer, by building products using the power of AI. While the ML engineer builds the models that, have these capabilities. So that's kind of the summary of it. Now, there's something I would like us to just, for the purpose of knowing, because as a person who is more or less in that area of being an AI engineer, you are building applications, you're using AI, you do need to know a little bit about the process that is followed in building these models. We're not going to go deep into it. I'm just going to talk about it kind of, um, you know, generally at a very high level. So the first thing that we all need to understand is that these models have to be built, they have to be trained, right? So there's a life cycle that we follow for training these models, right? The life cycle usually starts, it's a cyclical process, but usually starts from a problem that needs to be solved. So we have what we call a problem formulation, right? So you start from there. When you define the problem, then the next thing is you define the data that you need. You collect the data. When you collect the data, you prepare the data. After preparing the data, you have to choose an approach to use, a model architecture or an approach for training, right? The kind of method that you want to use to build a model. Then after you have done that, you go on to do the actual training of the model. And the training of the model is based on data, and there are various techniques, there are various tools that do that. After that, you do evaluation. Evaluation is where you evaluate the ability or capability of that model, how good it is performing on the problem area that was initially defined. And then after that is done, you now go to what we call deployment. So you deploy it either behind an API, or you deploy it to a server, or you deploy it as, you know, what we call an edge. An edge deployment is where you deploy it on devices that have less capacity, like, mobile devices, or you deploy them on, laptops. So there are certain models that are deployed that way as part of an app or something, or you deploy it as part of an API, but there are different ways. And then you monitor, and that's the production environment. So this will sound like, you know, basically the standard software development lifecycle, which is what we use, right? Especially for those who have some background in DevOps, you would have heard of SDLC and all of that. You even see in this graphic that I have here that you're actually seeing that you have a standard DevOps cycle that has kind of chained into or linked into a machine learning AI ops or ML ops cycle as well. The AI ops starts with formulate the problem, collect the data, curate the data, which is cleaning it and all of that, transform the data, then validate the data, then explore the data. You then send the data to your model. Not the data, explore the model architecture that you would use. So you explore, then you train that model based on the data. you evaluate the model. After you have evaluated the model, you would go back to formulating a new problem statement. A problem statement could also be something like, let's just improve the model. Improving the model is a valid problem statement. So it's not like we are going to create a new thing for the model to solve, right? But at the same time, it's also possible to say, okay, we want to do something new, right? Rather than let's improve. So anything you want to do with the model after that, you can do and you continue to do that. So that's the first thing, right? So you have that life cycle. Now, in this life cycle, where an AI engineer comes in is this second leg. So in this fused cycle, after the model is evaluated, we now have to build the products that will use this model. So you have to code APIs, code the products, build the products on the APIs, test. We are now going to a standard DevOps cycle of software development. You release, you deploy. So what you are deploying now is not the model. Model has already been deployed. But what you're deploying now is the application that is making use of this model. You operate it, you run it, you monitor it as usual. And then you plan again. So planning is planning for the application. After you plan for the application, you can see planning in a standard software development cycle teased back into formulate of the machine learning, development cycle. So when you plan from the use of the model, from what we have built, using the models, we formulate new problem statement and send it back to the ML ops, right? And they begin the whole cycle on that end again. Okay, so we have a new problem statement. We collect data based on that. We curate, transform, validate, explore, train, evaluate. So you finish that cycle and you have an improved model. Then that is passed back to AI, the AI developers who will take that model, that improved model, code, if there is any new code that needs to be written, build, test, release, deploy, operate, monitor, plan. And so it keeps going like that. That is how software development is going to be in the future. Of course, there are a lot of people who have already started adopting this kind of pattern because the future is intelligent machines, intelligent devices, intelligent software. So you have to work all of that into, you know, your software development lifecycle. And all of us have to become very, um, you know, adept at doing that. We have to become very used to doing it. It's not something that should be strange to us anymore. So that's the cycle. So having said that, we'll now go into talking about AI systems. So for today, we are really just going to look at, talk about a bit of the LLMs, and then we'll do a bit of hands-on. We'll have to set up our machine learning environments. I'll start off with the simple ones, right? And then after that, we can talk about more complex things, right? So now, what are the types of large language models that you will have to deal with? What are the types of large language models that you have to deal with? The first is, the types of AI systems that you have to deal with. The first is a large language model, right? So a large language model, I think most of us are familiar with that terminology already. A large language model is a deep neural network. It's a neural network that has a lot of parameters. If you look at some of the language models that we are dealing with in the world today, some of them speak of billions, right, of parameters. So that word parameter, like I said last time, represents a unit of how the knowledge is stored or retained in these language models. So it can be either a weight or a bias. It's basically a floating point number. And that floating point number, one of it on its own doesn't have any meaning. It doesn't hold any information. But when you have lots of it, right? They are tweaked and aligned in such a way that they have meaning, they store knowledge, right? And that tweaking and alignment of those floating point numbers happens when the model is being trained. Because when you are training the model, you adjust the weights. So for those who are in, who have done a bit of machine learning, you know what we call optimizers. So optimizers take the loss when you are training a machine learning model. The process is, first of all, you collect data. Like I've already said, you clean the data, you pre-process the data, you convert the data into numerical format, right? Because most, if not all, of these systems only understand numbers. You work with numbers, they only understand numbers. So those numbers get sent in as an input, just a bunch of numbers, right? Structured, yes, in its structured numbers, either as matrices or multidimensional arrays or matrices, right? So those numbers come in, and then those numbers get passed through the model, what we call an inference. So the model will calculate and give you an output. That output is also a number, but that number has a meaning or is supposed to have a meaning. Then, because you have training data, so training is a situation where you give it input data. These are the situations I want this model to predict, and then you give it what we call an output label or an output of what it's supposed to be. If I give you this set of inputs, this is the output you should give me. And that output is also a number that means something. It's part of data transformation. It will also, when you're transforming the input into numbers, you're also transforming the label, what the output should be, what the model should predict. You're also transforming it into a number. You present that number at the output. So when you do inference, inference is a process where the model takes the input and generates the output. Basically, it does prediction. So it's a mathematical process. It's basically taking in those numbers, doing a lot of churning of maths and churning out a number, right? That number is the model's prediction. You take that model's prediction and you compare it with what the actual value is supposed to be. And there's a difference. The model may not get it right the first time. So that difference is what we call an error. That difference is calculated using any number of metrics, something we call a loss function. It will calculate that difference and it will tell you, okay, there's a bit of error between what the model is giving me versus what I want the model to give me. You now take that error and you give it to something we call an optimizer. An optimizer, why it's called an optimizer is because it basically is an optimization process. The learning of machine learning models is an optimization process. What is the optimization process? That you basically want to minimize the error. In other words, the difference between what the model is predicting and what the model, what the actual value is, rather. So the less the difference, the more accurate the model is, and the better the model is at predicting. So you want to minimize that error. That's why it's a minimization problem. And that's why we call them, it's an optimization problem, basically. So you pass this error to the optimizer. The optimizer does what we call backpropagation, and there's a whole bunch of other things. It tries to basically reduce that error by adjusting the weights or the parameters inside the model. So the model is going to change based on what the optimizer does to each individual weight. So, or parameter. I tend to use the word weight a lot. Weights I really use in neural networks, but generally the general term is parameters. So you modify these parameters just a little bit, each iteration a little bit. Iterations can run very fast in seconds and so on. So over time, you now have an accumulation of adjustments that are done over time until you get to a point where the model gives you an output that is very close, if not almost the same, if not perfectly the same. Well, it will never really perfectly be the same. There will always be a bit of error, but you want to minimize that error. So the model will give you an output that comes very close to the inputs or to the targets, what you want it, the actual value you want it to predict. By the time the model has achieved that, then you can say that model is trained. because what it means is that whatever input you give to it is going to give you an output that matches what you want it to give you. Its prediction will match what you want it to give you. So that is the whole process of training. And so at the end of the day, right, why I've gone into all of that is to let us know that the whole thing is an optimization process. So when this output comes out, it comes out as numbers, but we now have your the code that will convert these numbers to the actual thing that you know we want it to be. And that's the process. So for neural networks sometimes have to have a lot of these parameters, right? In fact, the more parameters a neural network has, the better it is in inference or in prediction, in giving you the output that you want. So a large language model basically is such a neural network, right? And it's trained on massive data sets of text, right? These massive data sets are, you know, gotten from different sources. Most of the time is pulled from the internet. Like we talked about, you have spiders that can scrape and scrape data from different websites, and they form what we call a corpus or a corpora of data sets that you can then use to train the models. So based on that, these models are able to understand and generate text. And they're generating this text in a very intelligent manner because they have been trained on text. So essentially, a large language model, what most people don't understand is a large language model, when you send it a prompt, what it does when it responds to the prompt is it is trying to predict what an intelligent human being would have done in response to a similar prompt. That's essentially what it's doing. It is trying to mimic or predict, because that's what it's trained to do. It's trained to mimic. So it's trying to mimic or predict. And that prediction, it will be based on whatever prompt you give to it. And the prediction will be based on the data that it's trained on. So it ends up doing that mimicry so well, it becomes intelligent, basically. Is it really intelligent? Well, that's a philosophical question, right? But is it exhibiting intelligence? Definitely. Definitely. And that is the basis of the large language models. Now, the interesting thing that, I think everyone needs to understand, like I said last time, is the large language model on its own may not demonstrate as much intelligence as we are seeing, but we have people that fine tune it, add functions, add tools, add all kinds of things, retrieval, augmented generation, and so on. So these are all of the additional things that make these LLMs and the AI systems built from LLMs to appear or to demonstrate such intelligence. They're basically pulling data and they're able to manipulate the data and they're able to tell you a lot of things about the data based on the data they've been trained on. Now, the question is, can they demonstrate intelligence in the sense of coming up with something new, totally different from the data that they were trained on? Of course, that's what generalization is. That's what machine learning models are supposed to do, neural networks in particular. But there are times when they can go a bit off. So anyway, we're not going to go into that. So how do LLMs work? They are built on a transformer architecture. So transformer is one of the architectures that we talk about when we're talking neural networks. It's the most recent architecture when it comes to neural networks. And it's one of the most performant in a lot of fields. In fact, in many fields, what used to be the best of the state of the art have been replaced with transformers. From vision, it started with natural language processing, which transformers just became natural and solved all the problems. And then people thought about, where else can we use transformers? People brought into vision, And we have what we call vision transformers, VITs, which are really good, much better than the standard convolutional neural network, CNN based vision models. And then people brought into other things as well. So almost everywhere now you have transformers being used. So it's one of the best. I won't talk about what transformer is, but in this, because that's not really, it's just to give us a background. The other thing that the large language models can do is they can actually learn statistical relationships between words, tokens. It's a language model, so it basically deals with words in any language, right? So it has been able to learn those statistical relationships. Like if you give a sentence now, and you can ask it, give me a distribution, probabilistic distribution of the words in this sentence. How many of them are, this, that? It will give you. They are trained to predict the next token in a sequence. This is really what the basic, should I say, objective of an LLM is. I give you a set of words, a string of words, predict the next word. So the way this works is that it predicts the next word. That next word adds to the string of words you already gave to it. And that new string that is made up of the previous one plus a new word is passed back into the transformer as an input. It generates the next word. So it keeps doing that continuously and keeps generating words, and those words make sense. They are coherent. They are context aware. You can only achieve this with very large numbers of parameters. You cannot achieve this with just a few, we can try that anyway. So examples of training data that you have: websites, books, code, documentation. Whatever data or corpus of data you train a model on, that's what it becomes really good at. So take note of that. That's why you see some of the LLMs when you go and, oh, this one is better at coding, this one is better at this. It really depends on the data that it's trained with, right? So you could say, okay, ChatGPT does coding or Cloud does coding very well, but it doesn't have a lot of knowledge, general knowledge. That's because of what it's trained on. It's as simple as that. So that's a very important point to note. So common use cases for LLMs these days are used for almost everything. So for chatbots, for assistants, customer support, tutoring, coding companions, we all use that. All of these co-pilots, these are all LLMs now, right? Content generation, so you have blogs, you have reports, emails, documentation. Code completion, yeah, I just mentioned GitHub Copilot. Replit Ghostwriter. Data analysis, being able to explain data sets. Summarize research. Research summarization is a very, very interesting application. Another interesting application would be, I used to want this a long time ago, but now LLMs can do them. That is, a lot of websites and services like that, when you go to apply or to join or to create an account, they will tell you, read our privacy policy, read our terms, and these terms are sometimes very long, tiny text. Before you finish reading one, hours will go by. And I'm somebody that if I read, I like to take time to read. So I always ask myself, I would like to write an AI that can read the terms and conditions and then tell me whether I should go ahead or not, whether there is a hidden thing there or not, that kind of thing. Is there something wrong with this? And that is an application I'd like to throw out for some of you to think about. Like when you're building, can you build something that does that, right? I now see that a lot of these LLMs can do that. You just, pull the terms and conditions, throw it in, and it will tell you a bunch of things about it. So those are interesting applications. What we call, summarizing. These were things that were like big things in those days in natural language processing, but now LLMs just do everything. Then you have knowledge retrieval. So last time I talked about knowledge-based database or AI that are expert systems or knowledge-based based on people's knowledge. You still have that, right? So we have RAG. We're going to look at RAG in detail down the line as part of this training. So LLMs can be used for knowledge retrieval. Okay, I have a hand up. Ginika, go ahead. What's your question?
Okay, thank you, sir. Please, I want to understand. I know that um like these chatbots now and let's say the knowledge retrieval, even the summary you were talking about, like I thought is maybe the AI developers that take the raw data, the data that has been created by these LLMs and create features like this customer support, recommendation, policy summary that you talked about. Is it also the machine learning people that do that? Like it's kind of confusing who exactly does that. Because I'm trying, and the second question now is you said that this machine learning they like the big people use spiders in websites to crawl and gather data. Then the other people that are learning AI, let's say our fellow track people, how do they gather their data if they don't have that much information? Like, is it that it will not work how it's supposed to work? I don't know if you get the two of my questions, sir.
Okay, so the first question, um, the machine learning engineers focus on the models, right? And then they train the models. But they train the models on data. So the data comes from somewhere. There are actually a group of people who are called data scientists, that actually work with the data. In fact, there's what we call data ops. If I go back to a previous slide where I showed you this slide, you see what we call ML ops. ML ops are those who basically focus on the training, and deployment. AI ops are those who will use AI to automate. This one are specifically IT tasks in the context of data centers and so on. LLM ops are now, you know, ML ops that are focused on LLMs because LLMs are a serious area of business now. It's still ML, it's still machine learning, but large language models are a different thing at scale. Then data ops. So this is about collecting the data and prepping it and then sending it to the ML ops for the training, right? So you will see that in the context of machine learning, you see that there are new job descriptions that are gradually getting created. This is one thing everyone should note. We keep saying that machine learning will steal jobs. They'll take some jobs, but they are also creating new jobs, as you are seeing on this slide, right? So that's another opportunity for you to think about. I can just focus on being an LLM, fine tuning LLMs, right, and become really good at that. But of course, you still need to have the foundational knowledge. I can also focus on ML training, from scratch, or I can focus on AI, which is deploying basically and maintaining operations, right? Or you can just say, okay, I want to do data pipelines. I want to be able to, take this data in, clean it, and all of that. So to answer your first question, right, if you want to train a model, if you are ML engineers are going to focus on building the model and training it, right? AI engineers are going to focus on deploying it and applying it into products, right? So that users can use it. If you want to train a model for yourself, then you're basically going into being an ML. I don't know if that answers your question. I don't know if I grab your question very well,
Okay,
right?
so let
Is that
me use example like this chat bot or recommendation. Okay, customer support now for a product. Is it that the ML will gather data and train the model for customer support and
yes,
then the AI will integrate it?
yes. That's that's the correct answer, right? The ML will gather the data. Well, let's say the data people will gather the data, but you can also gather data as part of your ML because, like in the other course where we are teaching ML core, we're also teaching data gathering and management. So you gather the data, you design the models, right? But there are people who just focus on designing models, right? And okay, bring me the data, I'll focus on designing models. But it's good to be vast, to be broad, instead of focusing only on a narrow area. So you gather the data, you need to learn how to gather the data, how to clean it, and all of that, data pipelines. Then you train the model. But the chatbot itself, the person that will write the chatbot, in other words, the JavaScript code or the Flutter code or whatever that will use that chatbot, you're not going to deal with any data because you're dealing with a trained model. You're dealing with a trained model in the first instance anyway, right? So all you're going to do is call the API, send your question, and it will give you an answer. And we're going to do examples of that. I want to quickly get to that. But on the other hand, right, if you want to fine tune, then you may need to gather data. Fine tuning is, I just want to add a little extra training on top of the lots of training has been given to this model already. But I just want to train it in some areas where it is not very good. I didn't have enough training data. A good example is speech. I think I mentioned that last time. Most of the speech synthesis and speech recognition, models, if you speak an African accent, if you speak English with an African accent or a Nigerian accent, it will not understand. It will miss out some of the words. And the reason for that is because the training data didn't have a lot of African speech in it. So what will you do? You can gather African speech, voice recordings, audio recordings of African speech. That's now data pipelining. You gather that voice, you convert it into the format. There are standard tools for converting it. You are not going to write the tools yourself. You use it, convert it into the standard format that will be sent to these LLMs. So you can then use it to train, do some additional, that's fine tuning. Fine tuning is you do some additional training, and there are methods for doing that, right? Sometimes you can freeze some weights and train some weights or whatever. There are different methods. So you do that. Fine tuning is also another skill in itself. So you train and you basically have improved that model. You didn't build it from scratch. You probably will not be capable because you don't have that kind of compute, which is what you were saying. But you may have compute to just, fine tune it. And with that, with the additional data you've given it, it becomes better at picking up African accent in speech. So that's a good example. And there are many similar examples like that. The other way you could do is for some things that don't need that kind of fine tuning, you can basically just fine tune the prompt because the LLMs are so good when it comes to language. When I say language now, I'm talking about written language. You need to differentiate between spoken language and written language, right? A lot of the LLMs are really good with written language because they are trained on text. But spoken language, you still need what we call speech to text. So the spoken word needs to be converted. And so for you to be able to convert spoken words into text, there are different mechanisms for that. Even before LLMs and neural networks, there were other approaches for speech synthesis or speech recognition, rather. Okay. So there are those little things that you have to understand. There are those little differences that you have to understand. Okay. I can't remember the second question, but I hope I answered it. If not, you can bring
Yes,
it
sir,
up again.
you've answered both of them already. Thank you, sir.
All right. So I will continue. So yeah, that's talking about AI systems. So these are examples of AI systems that we can use and the API endpoints that you can use to access them. So I think I asked us to do a bit of a check and research on that. These are some of them. There are lots more. In fact, there's another slide where I kind of just pulled together all of them, and there are lots of them, right? I'm going to share that. I'm going to share that maybe at the tail end of this. So we have OpenAI has become really popular because they were the very first, in spite of the fact that there was a huge competition between all the big guns, in AI in the world to come up with this thing, right? It turns out that OpenAI was the first to come up with something. So that was very interesting, right? They beat Google to it, they beat Microsoft to it, they beat Meta to it, right? And they built that. So, well, OpenAI now they built ChatGPT based on their GPT, which is the generative pre-trained transformer, right? And that was the basis of ChatGPT and all the GPTs. And then, so you can see for OpenAI, they have different versions of GPT. They started from one, I think, but now they have up to GPT-4, GPT-4o, GPT 3.5, and so on. So you can actually access this by using that endpoint. Then Anthropic came up with Claude, Claude 3, Claude 3.5. That a lot of people are saying, oh, those ones are really very good with coding kind of task. They can figure out, a lot of things. I've actually tried it. I think it's quite good with coding, but you have to be your prompt needs to be very precise, right? Um, Typically, really complex problems can be given to these tools and this AI, and they will give you answers. Then we have the Google, of course. So Google came in a bit late into the game, but Google being Google, they effectively started flexing their muscle, and we have Gemini now. There were a bunch of other models before Gemini, which nobody wants to talk about. I can't remember their names that turned out to be almost a flop, right? But thank God that they were able to put in some work in there and they came up with Gemini. So Gemini is still being improved. All of them are still being improved anyway. So you can see that there is a huge competition going on there. So again, that's the endpoints that you can also use to access Gemini. Then Mistral. So Mistral, from the research I did, I have seen that Mistral has a bunch of open source LLMs that we can use. We are going to try out some of these things when we get into the hands-on session very soon. So Mistral gives us Mistral 7B, and this is available via the Hugging Face API. So Hugging Face gives us that. Then we have Meta, the parent company of Facebook, and Meta also provides us Llama, so the whole Llama series, right? In fact, there was a time I think Llama was open source, so you could, I, I think we still have a bunch of open source Llama models, right? That you can actually, when I say a model that's open source, you can actually download it, right? And if you have this strong enough hardware, you can run it. We will do some of that, but you have to have a strong enough hardware. You can actually download. There's an application called Olama, which will allow you to download a model and run it, on your own laptop. Do inference. So you give it prompts and it will give you responses. So we will also look at some of those, right? But of course, the hosted version is always the best. So we are going to do some of these demos, right, using this API. So I will do this with Jupyter Notebook when we get to the hands-on session. Okay, so those are large language models. The next type of AI system is what we call an embeddings model. So an embedding is basically a way of representation of knowledge, right? So in machine learning and in AI generally, there's a thing we call knowledge representation. You have to have a way of representing knowledge. If you cannot represent knowledge, you cannot manipulate it. And if you cannot manipulate knowledge, then you cannot exhibit intelligence. Intelligence is basically is something you exhibit. It's basically your ability to manipulate knowledge in logical, way. Reasoning is the ability to manipulate knowledge, but you cannot manipulate what you cannot represent. So in those old days, the representation of knowledge was done manually by human beings, right? Human beings will look for ways. How can I, in fact, we have what we call symbolic representation of knowledge and all of that, right? But that doesn't work because any way that a human being comes up with or any method would end up having some kind of limitations and some kind of biases because human beings inherently have biases. So the human biases will spill over into your knowledge representation approach, and that will eventually end up, creating limitations for your knowledge representation. So, but that whole idea was carried over into the machine learning period or machine learning era where we are now, where you can train, you can pass data into a model and the model can be trained on that data and it generates embeddings. So the embedding becomes a way to represent knowledge as numerical vectors. What do I mean by a vector? A vector is a string of characters or a string of numbers. If you remember matrices and vectors, right? A matrix is a two-dimensional vector. A vector is a list of numbers, basically. It could be integers or it could be floating point numbers, right? A scalar is a single number. This is in programming parlance for your information, not in mathematical parlance. In mathematical, parlance, a vector is different. A vector is actually um, something that has magnitude and direction. So that can be confusing. But in mathematics, in programming, what we consider as a vector is a list of numbers. Simple. So you have a list of 10 numbers. That's a vector. Now you could also, but what makes it a vector is the application of it, right? I can um, manipulate those 10 numbers in a single operation. I can say, for example, if you use NumPy right now, you can take a vector of numbers and you can multiply by 10. Each of those numbers will be multiplied by 10. And I can demonstrate that. So that's what a vector is. And you can have a vector of floating point numbers that represents knowledge, basically. But you as a human being, you cannot interpret what that knowledge is because it was generated by a machine learning model, right? Which was trained on data. So it kind of figured out, a way to represent that data so that it kind of makes sense. So that's what an embedding is, right? So an embedding model is a model that you can use to generate embeddings. So for example, every word, every sentence, every image, everything, every piece of knowledge that a machine learning model manipulates is always represented as a high dimensional vector, right? So, for example, 1536 dimensions. What is a dimension? So let me put it this way. A vector is a single dimension, has one dimension. A matrix has two dimensions. And what are those two dimensions? The column of the matrix and the row. The rows form one dimension, the columns form another dimension. You have a three-dimensional matrix. That is a matrix that has row, column, and it has depth, right? That's the third dimension. That's three dimensions. You get. So now that's what we call a tensor. So a vector is one dimension. A matrix is two dimension. A vector is three dimension. Please raise your hand if you have a question. Then so you can have n dimensions, multiple dimensions. A multiple dimension tensor is difficult for a human being to visualize because there's no visual equivalent of it, right? The highest visual equivalent of anything, of any tensor we have is three dimensions, which is like, think of it as a cube. Think of a Rubik's Cube. A Rubik's Cube has three dimensions. You are flipping it around. I don't know how many of us know what's a Rubik's Cube, but you're flipping it around in three dimensions, right? If you add a fourth dimension, it becomes difficult for us to visualize because we've never seen four dimensions. When we say time is the fourth dimension, it's not physically seen, it's experienced, you know. So Think of 1,536 dimensions. That gives you an idea. So embeddings, and it has to have such high dimensions because knowledge, there's so much knowledge. Each piece of knowledge has the representation has to be unique. So you have to have lots of dimensions to be able to do that. So typically, you have what we call vector space. Vector space is if you did a kind of mapping, if you were to visualize it and put it in space. I'll look for videos that will help to visualize some of these things. But a vector space is a way to kind of visualize these embeddings, right? So things that have similar meanings will be close together in that vector space. Things that have different meanings will be far apart. Things that have similar relationships, for example, male female, will have the same distance. Male female will have the same distance in that embedding space with boy girl, with man woman, but they will be placed in different points in that space. So there's a whole field of study that focuses on embeddings and how you can visualize them. So what do you use these embeddings for, right? Since an embedding is a representation, a unique representation of a piece of knowledge, a unique piece of knowledge, each unique piece of knowledge is represented differently. And if you have the same embedding, it means it's the same knowledge, right? So um, they are used for semantic search. So if you want to find relevant stuff, you first of all create an embedding, a whole set of embeddings. So you take a, a, a document or a passage, you convert it to embeddings, essentially convert each of those words. First of all, you do what we call tokenization. Tokenization is when you take a full text and you split it into tokens. A token is typically a word or a group of words, maybe two or three words, or one word or two words, right? Even the tokenization is not very you cannot use your human thinking to say, okay, this is how I tokenize it, even though in the past in natural language processing that's how it was done. I'm going to show some examples of that maybe when we get to NLP, how you run a paragraph or a sentence through a tokenizer and you see what comes out of it, right? So you can then tokenize. Then each token you do embeddings, you run it through an embeddings model. It will give you the embeddings for that entire thing. Then you can search through the embeddings. And anything you find, that's the best way to do search. Remember on Wednesday when I said I wrote an app where I was trying to build a rule-based AI so that if it's a bank app, if somebody asks how I want to open an account, what do I do? That's one way of asking the question. Another way would be, how do I open an account? Those are two, those are basically the same thing, right? But um, if you were to just use standard text searching or text matching, you will not get the same, it will not sound like it's the same thing, right? You will not, there's no way for you to figure out, these two questions are the same. But a way you can achieve this now would be take those two questions, tokenize them, and pass them through an embedding um, model. The embeddings that will come from those two models, there's also another function that you will use to calculate the distance between two embeddings. You find that the distance between those two embeddings are very close because the model has recognized that those two things mean the same thing. So the embeddings it will create for the first question, how do I open an account? And for the second question, I want to open an account. What should I do? The two embeddings from those two sentences will be very close to each other. That is the power of embeddings. And we are going to see how we can use embeddings to check for things like word similarity and all of that kind of stuff. Okay, then recommendation systems is another place where you use embeddings. Basically, with a system, a model that you have trained will generate embeddings that are close together for things that are similar. So maybe for something that you like, it can generate embeddings that are close, you know. But for something that you don't like, the embedding value, the distance, between what you don't like and what you like will be much. I'll explain this with actual examples later on. Then we have duplicate detection, which is detecting similar questions or sentences, what I just said. RAG systems. RAG systems, you use embeddings basically to store the queries in the vector database in RAG systems. So you can use that to retrieve additional relevant info based on embeddings. And then you append it as a system prompt, and then you send it to the LLM. So the LLM will get additional context for the question that a user has asked. Then you have knowledge graphs. Knowledge graph is still something that comes from the good old, rule-based AI, where information is stored as graphs. But this time around, we use embeddings to store the concepts rather than some, human-created representation of the knowledge. So that's embeddings. Um, so interestingly enough, most of these services can also provide us with a way to get embeddings for words. So we have text embedding 3 small. You can actually download the models as well and run, and you'll be able to get embeddings. So OpenAI has this endpoint that you can use for you to get embeddings. I need to double check this. Hugging Face also has, they have what they call a sentence transformer, which is a small model. You can run it yourself locally on your laptop, or you can um, just call their API and you can get embeddings as well. Cohere also gives us embeddings, multilingual embeddings. Voyage AI can also give you high quality domain embeddings, right? So this is an idea where you can compute embeddings for 2 sentences. The sky is blue versus it's a sunny day, and see how close they are. To compare similarity of embeddings, by the way, you use what we call cosine similarity. So we'll try these examples. Hopefully, we'll have enough time. Then the third type of AI systems is what we call vision systems, right? Vision models. A vision model is basically a model that has been trained to be able to recognize images, to be able to pull meaningful things from images, right? It will process the images or video, and then it can classify. So what we call image classification, what type of image it is. It can detect object detection. Basically, this thing is an object, that thing is an object inside the picture or image or inside the video, right? It detects what and what is an object, because not everything in an image is an object. There are some things that can just be, you know, um, an artifact, right? So how is it able to detect, and not just detect the object, but detect the boundaries of the object? So there is that. Then we also have, it can also segment and describe what it is that they see. So right now, currently there are two of the two models that are considered the best in vision are convolutional neural networks, CNNs, and then vision transformers, VITs, right? Like I said, transformers have taken over the world in almost everything. Transformers have proven to be better than most other models. But in vision, CNNs are still top notch, right? But people have found ways. The reason being that using a transformer for vision is very expensive. It's expensive in terms of compute. It will be slower, but people have figured out how to do that with vision transformer. I won't go into the details of all of that, but yeah. So what does a vision model do? It takes an image, encodes it into pixel tensors. So remember what I said. The data is the image, then it encodes it into tensor. A tensor, like I said, is a multidimensional vector, right? A vector is a one-dimensional tensor. A matrix is a two-dimensional tensor. So a tensor is a general name for data structures that are used, in machine learning in this context. So when you take an image, the model, you first of all encode it into a tensor that represents the pixels in that image, right? And then you extract the features, you map to labels or descriptions, right? That's what vision models do. They can extract the features and they can map to labels. Then you can also train these vision models. They can do recognition, whatever it is. segmentation. They can do counting. They can even do object counting. OCR is optical character recognition. So what does that mean? Handwritten, documents can be scanned. It will recognize the character that you wrote, or even printed documents can be scanned, and it will recognize the characters or the whatever was printed. So some of the use cases for vision models, we have image classification to identify is this an image of a cat or a dog. This is like the classical image classification problem, right? That people started up with. Is this a cat or a dog? So classification. Remember what I said about classification? Classification is basically saying, is this true or false? Is this a this or that classes, right? Then object detection is detecting and labeling multiple objects in images or in videos, right? Then image captioning is you give it an image and it actually generates a caption for it. This is what we call a sequence to sequence, right? Even though on the um okay, on the vision side of it, right? It's not a sequence model though. It's either a VIT or a CNN, right? But it has embeddings that, kind of have meaning as per what it is seeing in that picture. That is then sent to an LLM or an NLP sequence model, which would generate a caption. And that's a very interesting thing. And well, that's how it's trained. So you give it an image and it will describe the things that are in that image, right? Then OCR, optical character recognition, I already mentioned that. So you can extract text from images. Then medical imaging. Medical imaging is very useful because there's times when you could have some kind of artifacts or things in medical images. Examples of medical images would be things like an X-ray, or an MRI scan, or any of those scans, right? And it's difficult for human beings, human doctors, to identify what is in the scan, right? You can take lots of these scans and use them to train models. And when you train the models become capable of detecting what is in the scan. It's very amazing, that, but that really happens, right? So you can train them to identify tumors, to identify other kinds of things, things like that, anomalies in all of these medical images. It's now a really big field that a lot of players are getting into because of what AI can do in medicine. Then autonomous vision. So autonomous vision is where devices, machines, and AI can basically navigate around on their own with their own vision instead of depending on a human controller. So you don't need a human with a remote control controlling them, right? They can see for themselves. They can see the obstacles in their path. They can they can map the path that they have to follow. So good examples, of course, are self-driving cars, which have become a thing in the world today, drones, which can fly around autonomously on their own, and robots as well. So those are vision models. So yeah, we have some really strong service providers that give us vision models. OpenAI. If you actually take ChatGPT, you can upload images into ChatGPT, and it will tell you, about those images. You can even use it for something. One good example of what you can do with vision, I've done it, and I think there was some discussion about that. I can actually take a design or screen grab a web page or take a Figma design, upload it to ChatGPT and ask it to generate HTML for you with not just HTML, but with what do you call it? Tailwind CSS. It does it clean. I was I was gobsmacked. I was surprised when I saw that. But yes, that is the level of capability of some of these LLMs, what they can do now. So because those are the ones we now call multimodal, and we'll talk about that shortly. But because it knows how to do it basically will generate HTML that comes close. It may not be perfect, right? So you still need, as a human being, you still need to do a bit of cleanup and all of that. But it's a starting point. Then you can go fine tune it, right? Fine tune the HTML or CSS, and you have it. So yeah, Google has Gemini Vision um, through an API called Vertex AI. So this might be a paid thing. Hugging Face really focuses on images. So Hugging Face has Clipsam, Blip, and they have AI APIs for that. AWS has Recognition. Recognition is basically an AWS service that you can upload images and it will give you image recognition, as the name implies. Then we also have Meta that has SAM called Anything. So these are all some of the um, tools that we have available for vision. Then we have speech models. So speech models, you can use it for speech synthesis, for speech recognition. Uh, Audio to text is speech recognition. In other words, the speech is recorded as an audio file, whether it's MP4 or MP3, right? Or any other format, WAV or something. It will recognize and generate the text from it. And we'll do a few examples as well. Then text to audio is the opposite, the reverse direction, which is speech to text um, speech synthesis, text to speech. So a lot of them these days use neural networks, recurrent neural networks. They use transformers and conformer. Conformer is basically a combination of convolutional neural network and transformer. That's why it's called conformer. So we have types of automatic speech recognition, which transcribes spoken words, you know, into text. Then you have text to speech, which generates a natural sounding speech from text. We have APIs, or we even have functions. Most programming languages these days, or programming frameworks, JavaScript, well, I don't know. I know that Python has it. I know that Android has it. I know that iOS has it. So if you're using Flutter, for example, you can access their speech interface. And I think a few people have, in fact, in KodeCamp, there's a project we call um, WordWiz, which uses speech synthesis and speech recognition. It uses those libraries. So those libraries are already there. You don't even need to stress yourself. But one thing you find is that sometimes the speech recognition or speech synthesis may not be very clean. So a good model will give you much better, much cleaner, stuff. But a model that is not so good might not be able to give you such a good production. So it also still depends on the size and capacity of the model. So something to take note of. So common use cases, we have voice assistants like Siri, Alexa, Google Assistant. Then transcription services that can, use for meetings. Some of us have all of this AI that join meetings. As people are speaking, it's transcribing and taking meeting notes. That is speech to text, right? Or speech recognition. That's what that is. Okay. So you can also build one yourself. It's good to know how these things work because you'll be wondering how do these things even do this, do what they do, right? So you can build your own tool that would be able to listen in, join meetings, and then give you the minutes from those meetings, right? Um, then call center. Call center is a really good application. In fact, somebody told me just this morning that there is a huge opportunity in call center, in Nigeria and Africa, AI-based call centers. So you can actually write AI applications that will basically um, pick calls, forward them, handle the calls, or handle issues, right? Then if the issue is too difficult for the AI to handle, right, the AI can forward it to a human person, who can then handle the issue. So this is all very interesting. These are all ideas that I would like each and every one of you to think about, you know, is this something I can implement? What will it take for me to implement it? What should I do in order to implement it? So it's very interesting, but yeah, you can do all of that. Um, then the final one is okay, these are the tools that are available for speech recognition. So OpenAI has Whisper. I think Whisper is, I think, probably the most common one. I don't know if I should say it's the best one, but a lot of people keep talking about Whisper. Whisper is really good and can do a lot of stuff for you. So you can even download the Whisper model. That's one thing with Whisper. They have open source models that you can download and run in your own laptop. So just to play around with it, because the benefit of being able to download models and run in your laptop is you may not have enough money to pay for, um, the hosted ones. But one thing you need to note is that if you download a model and run in your laptop, if you don't have a really good GPU, you have reduced capabilities. In fact, you may not even be able to install some of those models, or it may not even run. But some will run and they'll be slow, or you may have to use smaller versions of those models, which will, you know, it may not give you the outcome you want, but okay, at least it's still better than nothing, right? So, but if you want really good, you know, um, production, you use the hosted versions. If they have free, then you can just access them. The free ones typically would be limited to a bit of um you know you can only use a little. You have what we call rate limiting or usage limiting and so on. Okay. Then Google also has speech to text and text to speech. Like I say, Android has excellent speech to text. Like if you are writing Android apps, you will find that speech to text and text to speech is very clean. You choose voices, female or male voices. If you have internet access, it's going to be much cleaner. If you don't have internet access, it will sound robotic. So that's to tell you that those ones that sound very nice, the models are actually hosted on Google servers and it's sending the data to the Google server and getting the sound file back. But if you don't have internet access, then you have the one that sounds a bit robotic. That means it's using a smaller version of the model that is running on your phone, but it's not very capable, so it can't give you very clean sound. Azure has the same thing, speech service, recognize, and then assembly AI deepgram. So we could do this, but I won't be able to do this today because being able to record, I don't have recordings, but we can try. Okay. Then the last but not the least is what we call multimodal models. So a multimodal model is basically an AI model that can process, and generate multiple data types simultaneously, right? It's they call it modalities. So it can understand context across multiple modalities. So you can upload an image, for example, and tell it, look at this image and tell me what is wrong. It's awesome. Like they have basically broken that barrier. Or you can upload a sound file and say, okay, give me a transcription of what was said in this and explain to me. You know, you don't need to even tell it what is in the sound file or what's in the image. Just upload the image and tell it to use the image and give you something. I gave an example just now. I uploaded an image of a website that uh, a website design, and it generated the code for me, including Tailwind and all of that. So a multimodal that's like the standard now. Any big AI company, all of these big players, if they don't have multimodal models, then they are not serious, right? So they work by combining text and visual encoders into a shared latent space. So what is a latent space? Latent space is a space that holds knowledge. Basically, latent space is like where all the information or knowledge kind of comes together, right? So a shared latent space means that the visual input that you send to it, the audio input that you send to it, the embeddings, the speech, all of those things that you send to it, it it pulls them all together and it's shared. So that's why it's able to caption an image because the embedding of the what is contained in the image, the part of the it's the same model basically. It's not like it's two different models. One is doing recognition, and the other one is generating the caption. It's the same model. So it knows what it sees and it knows how to generate the caption for it. And it's really amazing. But how they're able to achieve this thing is because of the huge size. The huge size. So it also enables complex reasoning because you can, like I said, you can upload a meme or an image and say what's wrong with this image, and it will tell you. So common use cases: visual question answering. What color is the car? You upload a picture of a car. Say what color is the car? Image and text generation. So DALL-E and Midjourney are really good examples where you can ask it to generate images. You give it a description of a scenario or a scene. In fact, these days, a lot of companies that are focused on things like um, what do you call it? Video AI videos. You can actually just give it prompts and it will generate videos. Multimedia assistance to analyze documents, charts, screenshots. Product analysis to describe or rate a photo of a product. Interactive apps to take photos, um, describe and respond with speech. So all of these companies have such tools. OpenAI, Anthropic, Google, Hugging Face, right? That have multimodal capabilities. So this also is a demo idea which we will look at. So this is a summary of this, and I think this is there's something else I would like to share before we do maybe about 30 minutes of hands-on. I spoke about some of these LLMs, but it there are lots of them. It's not just OpenAI and Anthropic or Google. These slides here will tell you the numbers. So some of the big guns, major proprietary ones, you have GPTs from OpenAI, right? You have Cloud from Anthropic, right? With high reasoning accuracy, long context windows. You have Gemini from Google DeepMind, right? From Google DeepMind. It's multimodal, integrated with Google Cloud. You have Grok 1 to 4. Grok comes from XAI, that is Elon Musk company. And Grok, the interesting thing with Grok is it's integrated with X, with Twitter. So Grok's data stream is Twitter. Just imagine that. You understand? It's getting data constantly from Twitter to be trained on. So it is getting really good at learning and knowing things that are going on. Amazon has Nova in the AWS, you know, stream. Then you have Phi 3 from Microsoft. Then you have other proprietary ones. You have Jurassic 2, Jamba. You have Inflection 2.x, right, from Inflection AI. You have Qwen 2. Qwen is a recent one that just came in from Alibaba, AliExpress, and all of that. Then NVIDIA even has Nemotron 4. Then you have Palm 2 from Google again. You have DeepSeek. DeepSeek just came and like scattered the whole place, and everybody started shouting DeepSeek, DeepSeek. They made some really huge models that, okay, let me not say huge, highly capable models that were very small and very fast. They basically flipped the whole idea of, oh, a model has to be really big before it can do stuff. So you have DeepSeek version 3 R1 from DeepSeek. Then you have a bunch of open source, open weights. Open weight means you can actually download their weights. They have a GitHub repo or somewhere you can go download their weights and run. And what I mean by weight is the parameters themselves. It's the parameters that makes the model, right? If you don't have access to that, you can't do anything with it. So Llama is a good example of open ones that you can download. That's from Meta AI. Then Mistral 7B, Pixtral, you know. Mistral is the initial one. Mistral is probably multimodal. Pixtral is image. Falcon 40B, right? OpenAI has GPT open source that you can also download. Stable LM2 from Stability AI. Then you have a few community-driven LLMs that communities have trained and made it available. So you have MPT7B as example from Mosaic ML that is now Databricks. You have Pythia from Eluita AI, Vicuna, Red Pajama. There are so many. So um, then you have others from other parts of the world. So you have, for example, Yi. This is from China. You have Gemma from Google Research. This one is a lightweight open model for teaching and research. You have Arctic, Snowflake. You have Command R, Aya, JICE. So you have all of these, and we will look at some of these, maybe not all, but we'll be able to use some of them. So I'll stop here. Are there any questions before I go into hands-on session and we just do a few things? Any questions? All right. So if there are no questions, let's try a few things. The first thing I want to do, I use Jupyter Notebook because I don't need to install lots of stuff and it just makes things easier for me. So the first thing I want to try is this. I want to see um, I want to see if I need to get, so first thing is, let me start with my notebook. Collab.new will give me a new notebook. Now, what I would like to do is call an API that maybe I'll use I'll use OpenAI. So the first thing is, if you're using OpenAI, you have to get an API key. Okay, so it's very important. You have to get an API key. So if you open the OpenAPI platform, I don't know if we can then I think you need to get an uh, okay. So to get an OpenAI key, the first thing is to go to platform.openai.com. So we'll go there. If you have already logged in, right, you will be able to get a key. If not, then you log in. I think I already have, so I have to log in. I hope I can remember my password. So remember, it is platform.openai.com, right? So I've logged into OpenAI platform now. So after logging in, you get a key. So if you scroll down on the right, you'll see, let me see, you see API keys. Let me just search API keys. Okay. So um, okay, this is docs. I don't want to go to docs. I want to open the platform. Developer mode.
Sir, hello, sir.
Yes.
You can go to the URL platform.openai.com/API keys. It will get you directly
Yeah.
to the page you are looking for.
I don't know why it's redirecting me to documentation. Okay, let's check it here. All right. So well, let's just go straight there. I'll figure out how to do it from the. Okay. All right. So if you, this is the link. Let me share this link so that everyone, if you already have an OpenAI account, that would work for you. So, um, all right. So you create a key. So you just click on create a new secret key. You can choose a service account or you can just do personal, right? But let me just simplify it first. So we just say testing key, um, default project. That's also create secret key. So this key, remember the key, they will not allow you to see it again. So you have to make a copy. So I'm going to copy that. Then I'll go back to my, I'm going to use Python for this. So of course I'm using Jupyter. So I'm just going to store it here. Since I'm doing just a demo, I'm not going to overflock the matter. So I'll just keep it here first. Now, um, so we're going to try out a few things like how do how do we even you know um, access the you know API endpoint. So we're going to look at the API endpoint shortly. So let's see. Go back to this. So you see the endpoint for GPT is completions. So completion is like the very basic endpoint. If you want to just, that's why it's called completion, right? I hope everyone is seeing my screen.
Yes, sir.
This their new, this thing is so tiny. AI for developers. Week one. Okay. Don't know why this thing is so tiny. Maybe it's from my laptop. Okay. All right. So we have OpenAI key, we have API endpoint. Now you're going to do a simple call, right? Um, we're going to do a simple call, right? Um, let's just do an API call instead of so we will import requests. Then we will call the request. So response equals um, now the thing is, first of all, I need to even check the documentation, which is probably the first thing I should have done. So let's see, open platform. Okay, so these are some of the examples that they have. So you can actually use their clients. They have a client which you can get from if you're using JavaScript. Um, I'm looking for Python. Um, read and generate text. So let's just try something. Text generation. So for this one, they're using this, but I want to see if I can just use my own. So I'll do this, right? Instead of doing clients, I'll just call. But the main thing is this payload is what I'm looking for. So the payload is made up of two things primarily. You decide which model you want to use, and then you specify the input. So this is like the very basic thing that you can do. Then it's going to give you an answer, a response. The response is the type of response, the role, and then the content. So type is output text. This is the text. This is now what you use and print. So uh, so let's put that in here, right? So I'm doing a post request. It shouldn't be a get. It should be a post request. So I'm just going to put the API endpoint. I already have it. Okay, I thought I had copied this, so I may copy this. All right, so this is not JavaScript, this is Python. So we'll do this. Okay, we'll send in a dictionary. Okay, then we can now do response. So let me just put this in a try block. Response raise for status. So I have collab, which is why it's doing all of this nice stuff for me. Um, data equals response.json. And then you can now print it. Okay. I'm not doing it this way. do it the way I want to do it. Okay, so let's try this and see what happens. I hope I did not make a mistake. If I make a mistake, we'll debug it. All right, unauthorized URL. Okay, so I forgot that I'm supposed to put the API I'm actually going to speed things up. I'm going to add GPT to solve it for me. Okay, so um, all right, the API should be passed in as a token. I think I have that. I don't know how I managed to get that. So we can say headers equals. So we have authorization header, and it's a bearer token. So open AI key. Okay, that's completed the rest for me. So I have to have the headers. I put the OpenAI key as a bearer token. Then the payload is still there. Um, so then I just call. So put the headers. Then I put JSON. So let's run it again. Okay, too many requests for URL. This feels like it's already rate limiting me, but I didn't even do anything. Or maybe because I didn't pay money, I don't know. Let me remove this payload and put it here. So let's see if I can change this payload to, they are recommending something for me. Oh. So this is where if you want to separate system prompt from, you know, a normal, so this first message contains a system prompt. So remember what I said when I talked about system prompt. I said a system prompt is the one that you can use to further fine tune the real prompt. Then the user prompt is the actual one that you get from the user. So I can even say user input equals, and this is a user input. I can even do that. Okay. Tell me about flowers. Okay, so here the content will be the user prompt, which is user input. Okay. Yes, I forgot GPT-5 is actually not free. So I need to go to a free one. Uh, which which chat GPT is free for API access? GPT-4 and GPT. Okay, so let's try 4. Okay, if I try 4, it doesn't work out. Try 3.5. Okay, so let me run this now. Um, Client error not found for URL. I don't know what that means. What did I miss? Didn't change anything. GPT-5. Okay, maybe there's nothing like GPT-4. GPT-5 is saying too many requests. So let's see 3.5. Okay, 3.5. 3.5 is still saying not found. Okay. Yeah, okay. HK says double. So let's try double. Again, too many requests. So I don't know if I need to do a subscription. I actually thought I would just come in and at least I can have two or no for API access. They don't have. Yeah, the API access is not free. Okay, so what other option can we use now? Um, which one have I used before? I can't even remember. Um, let's try Atropic. Does Atropic have, is Atropic free? Gemini. Hugging Face has. Let's try Hugging Face. So, yes, Ngozi, go ahead if you have a question.
Yes, I wanted to say that can use Open Router. That's one I used because the Open AI tool did not work for me.
Okay, can you check, post the link for me? Let's try.
Okay, sir, let me
So,
try to get it.
your first API call, let me see. So, frankly, how do we access Gemini? Do you just use this, their endpoint? Let me try a new code block. So, Gemini API. Yeah, DeepSeek should be free actually. I don't know why I didn't even remember DeepSeek. Okay, so let me just. I don't have a DeepSeek account too. All of these places, the only one I have account is Gemini. Open router. Do I have to create an account? Okay, so Gemini. Okay, let's try Open Router. Uh, Hugging Face is taking time. I thought I had a Hugging Face account. Funny enough, you look at all of these guys, you see that their websites all look the same. It's probably the same front end they're all using. Okay, Hugging Face is. It looks like I had a Hugging Face account too. I can't remember the password. Your password has been exposed to 940,459 known data breaches. You can check. Have you must set a new password here. Okay. Okay. All right. No worries. Set password. Jeez. Okay. All right. Um, choose the food normally eaten off a plate. Ah. Okay. Okay. So I have a Hugging Face account. Um. All right. So they even have sample code here, and it's still OpenAI. Okay, so they are using OpenAI interface as well. The only difference is that it is this. So, how do I get the key token? So I'm not going to do all of this because the code is already there. We'll just go look for a token. So where can I get the token? They've already shown the code here anyway, so let's try a new code block. So hugging face, hugging face API. Okay. Key. Basically, these guys are not writing any code. They are just training models, which is why they're all using the same thing. They're using OpenAI's client. Uh, okay. So where do I get the key? They're even using OpenAI. No, this is OpenAI. This is Hugging Face. So Hugging Face basically still using OpenAI client as well. Um, but where do I get the key? Don't need to read all this. Yes, where do I get the key? Settings, access tokens. Okay, so I'm going to create a new token. Well, how can I please confirm your email address before creating? Okay. Okay, so I have to do email stuff first. Let's see if I can do that real quick. Okay, I can see the email. So I should click on the link. Click on the link. Let's confirm you are human. So this is what came from clicking on the email. So there are passing me through some captcha. Guys are crazy about captchas. Cartoons. So they give me real cartoons. They also give me their own image. Remember when I told you that some of these guys are using it to label some of their stuff. They're using it to label some of their stuff. Okay, anyway, that's cool. So let me refresh this. I can now create access token, um, testing, make calls to inference provider. Do I need to go through all of this? I just need read write, right? I need to read write. Just I don't need fine grained. Okay, so I copy the token, put it in here. All right, so now I can make the API. Let me make a function so I don't keep stressing. So I'm going to take all of this and put it into a function and say def call um, API call AI and API with prompt. Then I'm going to put prompt and then I'm going to put system prompt. And then I'm going to put um, so then def init self API endpoint API key so I don't kill myself. So I can now do self dot API endpoint self API key, then call with system prompt, call with prompt. Do you have prompt? Do you have system prompt? Do you have model? I think we should even have model here. Default model equals model none. Okay, so API key default model. So default model, yeah. Okay. So call with prompt. So calling with prompt is all these other things I did. Jeez, I've thrown away the whole code. Okay. All right. I think I copied and I did not paste and I lost it. So, but good thing. Let's see. So first of all, we start by saying response equals request dot post URL should be self dot API endpoint data headers equals headers. So I can do headers equals authorization self dot API key. Call with prompt. I need to put self first. Content type. Okay. Response is request for self API headers payload. So payload. The good thing is that all of these things, the payload is basically the same, right? So you specify the model, if model else self the default model. Then messages. So system prompt. System prompt. Okay. Or you can just make an empty if there's no system prompt. Or we could make system prompt default to empty string. So system prompt equals an empty string. Okay, then the prompt temperature. I don't know about temperature. Okay. So yeah. So this works. I can now run this so that I have this. Then I can just come in here and say Hugging Face, HG face, HGFC equals, I can use this AI client. I can specify the API, Hugging Face API. I don't know which model that they have. Then I can just um, okay, there's some other stuff I did here. I forgot. Try um response dot raise. Okay, it remembers. Um, so return response at JSON. Yeah, I just do that. Okay, so I have to rerun this code block so I can get everything. Then, so I just do hgfc dot call with prompt. Um, tell me about flowers. Okay, so run the block and see if it will work. Okay, so there's problem in my code first. Missing one required positional argument. Default model. What is a default model I can get from Hugging Face? Models. Interestingly, okay, Hugging Face even hosts lots of models. This is nice. I like that. So if I just copy, I can say DeepSeek OCR. Oh, this is OCR. Can DeepSeek OCR? I just want text generation. Just text generation. Is interesting. Okay, so OpenAI has Hugging Face is really nice. I just discovered this now. I wasn't paying attention to Hugging Face. Hosting a lot of models, and you can access these models simply by, you know, let me see. So even the OpenAI GPT open source 20 billion parameters. How do we access it? Let me be sure. This is the model ID. But can I just pass that in, or I'll have to use their own thing? Okay, these are just the models. They're not hosting it for us. So because they're not hosting it for us, I can't use it as default model. Let me see if this works. Uh, so this API that we have here is really specific. This API is not working. Okay, let's try open router then. We need to get one that works. Okay, so open router, sign up. Okay, so they sent me an email also. Uh, uh, I have to click a button. When I click the button, they'll bring me here. So they'll bring me here. So I'm signed up. Now I need to get the, so you go to keys, I guess, to get the key. So you have API key, create API key, testing. I don't have any limits. Create. So I have this key. Um, but the thing is, okay, now I have this. Um, I think their API is different. I thought I could just call the API, but I need to check what their documentation. So it's interesting that for all of them, this OpenAI SDK, which I didn't want to use. Hey, this is what I want to use. I want to use this. And this basically is the code that we just wrote. So let me confirm. So the first thing is to get the correct URL. So let's go back. So now try the same thing again. This time we'll use open router. So open router API equals open router key equals. So where is the key? I had the key just now. Ooh, did I lose the key? I guess I did. Ooh. Oh, I copied it, but I didn't keep it. It wasn't on this window. Okay, there it's that window. Okay, so all right. So I'll copy the key again, and I'll put the key here. So if you look at this open router, their code is exactly what we wrote, what I wrote. Authorization is bearer key, HTTP referrer. The only thing is the HTTP referrer, which they say is optional, so I'm not going to bother. X title, which is optional, so I'm not going to bother. Then data, you do a JSON conversion model, OpenAI GPT 4.0. So yes, so let's make this your default model, which by the way is also optional, but I'll come to that. So I'm going to do open router RTR equals do my AI client open router API. I'm going to use, oh, it's even smart enough to figure that out. It's GPT 4.0. OpenAI just GPT 4.0. Okay, then call with prompt. Tell me about flowers. Let me confirm the other things. So the format is model, messages, role. So it's the same format, right? It's the same format, so it should work. Okay, let me run it now. It's now saying payment required for this. Okay, so which one is free? We need to pay for 4.0. Are there any free ones? This, I think this is the issue. Go ahead. Who raised their
Yeah,
hand?
3.5. 3.5.
3.5 is free. Okay, cool. Thank you. That's GPT-3.5, right?
Yes, sir.
Okay. Ah, bad request for URL. So did I miss
But
something?
GPT, where did you have it written? GPT hyphen 3.5 hyphen turbo v2.
Okay, trouble. Are you sure that's the problem? I don't think so. Is Turbo still says payment required. 3.5 did not say payment required, just said bad request. And I don't know why it is bad request. Um, hmm, maybe the temperature. Let me remove this temperature. They don't have temperature in their own stuff. In their own stuff, what they have. Let me stop the recording so that it doesn't get too much. We can keep on doing this.